Hello there, Algebra 2 students. Mr. Weber here. Today we're going to start a brand new unit, and I think you guys are really going to enjoy this because compared to our last unit, I think you're going to find it much more straightforward and much more accessible. So I do want to remind you this comes from pages 483 to 489 in your textbook. So if you have any questions, please make sure you go back and you're looking at that resources. So today we're going to start talking about probability. And so before we can jump into probability, we've got to start with just plain old counting. So we're going to talk about the fundamental counting principle. Easy as 1, 2, 3. Not really that easy, but pretty easy. You're gonna enjoy this, I think. It's a couple things you got to know, and if you know those things, it's going to be really straightforward. All right, you will need a calculator for this, so if you don't have one there right by you, go ahead, pause the video, go grab yourself a calculator and a pencil, and come on back. Okay, so when we're talking about the fundamental counting principle, we're not talking about counting like 1, 2, 3, 4. You guys can do that, hopefully. What we're doing is counting about how do we count like large things, different ways things could happen. When you have multiple different options or multiple different rules for what each item could be, if we're selecting multiple items, how can we think about the total number of possibilities that we have to choose from? That's what we're talking about with the fundamental counting principle. Okay, so here's what it says. It says that if there's A ways to do event 1 and B ways to do event 2 and C ways to do event 3, then A times B times C is the way to do all 3 events. The easy way that I use to remember this is when you have multiple events, you have to multiply. Okay, when we have multiple events, we have to multiply. So if we want to know our total number of possible outcomes, we're going to take the number of choices we have for each criteria or each category, and then we're going to multiply those things together. All right, so here's number 1. Let's go through. We have 10 examples today. Hopefully you'll feel like a pro, and then you can go ahead and do the assignment and do great on the quiz, and everybody's going to be happy. All right, so here we go. To make a yogurt parfait, you choose 1 flavor of yogurt, 1 fruit topping, and 1 nut topping. All right, so the question is, how many different choices out there of parfaits do you have to choose from? Okay, so let's think about what we have. We have a little graphic over here. So in terms of flavors, how many different options do we have for flavors? We only have 2 options, plain or vanilla. All right, how many different options do we have for our fruit topping? 5. And then how many options do we have for our nut topping? 3. Now, what you have to remember is that even though we have multiple options for each of the events, we're only going to choose 1. We're going to choose 1 of the 2 flavors. We're going to choose 1 of the 5 fruit toppings and 1 of the 3 nut toppings. So we're choosing 1 of each, and we're thinking about how many different parfaits are there that we could potentially pick or choose from. All right, so we have those 3 total options. So there are 2 flavor options, 5 fruit options, 3 nut options. All we have to do is multiply those 3 numbers together. 2 times 5 is 10. 10 times 3 is 30. There are 30 different options of yogurt parfait that we have to choose from. That's it. Think about your number of options and multiply them together. Pretty easy, right? All right, it's going to get a little more complicated, but it starts off pretty good. All right, so here we go. Number 2. So ordering a pizza. We have 3 choices of size, 2 choices of thickness of crust, and 8 choices of toppings. All right, so how many different pizzas can be ordered with 2 different toppings? This is a little bit interesting. This one's a little bit trickier of a problem. So let's look at it together. So the first thing we got to think about are the different events or the different options that we have. But what's the first thing we have to choose? We have to choose the size of the pizza. So we have 3 different choices for sizes, probably a small, medium, and large. All right, so I have a size category, the number 3 there. The next thing we have to choose is our thickness of crust. All right, so how many options do we have there? We have 2 choices for the thickness of crust. And now here's where it gets a little complicated. We have 8 choices for toppings, right? So when we go to choose our first topping, we have 8 different toppings to choose from. All right, but look at what question A states, how many pizzas can be ordered with 2 different toppings? Which means that the topping we choose for our first topping, we cannot choose again. Can't be like my kids and say, I want cheese and extra cheese. It doesn't work that way. All right, you got to choose 2 different toppings. So when we select our first topping, we have 8 different choices to choose from. But when we select the second topping, since we've already chosen one topping in our first criteria, we don't have 8 choices anymore because we can't choose that same topping again. It has to be a different topping. So now we only have 7 possible choices for our second topping. Does that make sense? Okay, again, all we're going to do is multiply those things together. 3 times 2 times 8 times 7. Here's where a calculator would be handy. It's going to equal 336. So there's 336 different pizzas that you could order if you're going to choose 2 different toppings. Okay, now look what happens if we have to choose 3 different toppings. So B says how many different pizzas can be ordered with 3 different toppings? Well, this starts off exactly the same as the previous pizza. So I'm going to just copy over everything that I just did. Still have 3 options of choice for size, still have 2 options for crust, 8 options for our first topping, 7 choices for our second topping, but now we're going to have 3 different toppings. So for that third topping, remember, I can't choose the topping I chose for topping 1. I can't choose the topping I chose for topping 2. So now I only have 6 possible toppings I have left to choose from. Okay, so the number of choices I have for that third topping is only going to be 6 because I've chosen a topping for topping 1 and a different topping for topping 2. All right, multiply those things together. Grab your calculator. 3 times 2 times 8 times 7 times 6. Beep, boop, 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 beep, boop, boop, boop. 2016. 2016. Can't even talk right. 2016. That makes sense? Questions? Hope not. If I make a mistake on this, which is possible, send me a message. I'll fix it. All right, number 3. Okay, so you're going to see where things are going to get a little more complicated. And 3 is a great example of how it can get a little complicated. So think about passwords for your computer. I do like this because it is a very real world kind of scenario. And hopefully you can see why they make you have all these criteria for different passwords after this problem. All right, so a password for a computer site consists of 4 digits followed by 2 letters. The letters A and Z are not allowed, and each digit or letter may be used more than once. How many unique passwords are possible? So every single line there is important. All right, so we're going to create a site that's going to consist, a password that's going to consist first of 4 digits followed by 2 letters. All right, so I have digits, I have letters. Let's think about how many different digits are there. Well, start at 0. You have 1 through 9 and the number 0. That's a total of 10 different digits. So you have 10 different numbers that you can choose from when you're building your password. My password could be 1, 2, 3, 4. It could be 2, 2, 2, 2, 2. It could be 1, 5, 3, 9. Something like that. I have 4 digits. Now, how many letters? Okay, well, look at the next sentence in the problem. The letters A and Z are not allowed. Okay, so what that means is there's 26 letters in our alphabet. We're going to subtract 2 because we can't have A or Z, meaning we only have 24 different options for letters. Okay, I have 10 different options for numbers. I only have 24 different options for letters. All right, so let's think about what our password is. It's going to be 4 digits, 2 letters. So I'm going to put kind of 6 blanks right there. All right, 4 digits, 2 letters. I missed animation on my multiplication, but don't worry about that. All right, so now the first 4 are digits. So how many different options do I have for digits? 10. So it's going to be 10 for each of these options. So each line here represents 1 letter in my password, and the number here represents the number of options I have to choose from for that particular character, whether it's a digit or a letter. Okay, my last two digits are, our last two characters are going to be numbers. Letters. How many different options do I have? 24. So this is going to get big, but literally you're just going to do 10 times 10 times 10 times 10 times 24 times 24. You're just going to multiply the options you have for each of those characters. You're going to get a really big number. Beep, boop, 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 beep, boop, boop, boop. 5,760,000 different combinations. Yeah, crazy, right? Think about what would happen if we added more digits. That number would get big. So, real world scenario here, if you ever want a very safe and secure password, make it longer. The longer it is, the more possible options that it could be, and the harder it is for someone to kind of crack it. Okay, so what I would encourage you to do now is to kind of pause the video and try to do number 4 on your own. It's much more straightforward, just to see if you get the concept. And if you get it right, then we'll just keep on going. Number 4 says, make your own adventure story. I used to read those to my kids. They're really, really fun. So this story lets you choose 6 different starting points. It gives you 4 different plot choices. And then it has 5 possible endings. All right, so how many different adventures are there for you to read through? All right, so let's go through this step by step. I have 6 different starting points. The next choice I have is in terms of plot choices. I have 4 different options there. And the next choice I have is in terms of possible endings. 5 different options there. Okay, so all we're going to do is multiply 6 times 4 times 5. Grab your calculator. 120 different stories that I could tell from that make your own adventure story. Kind of cool, right? That means you could read this book 120 different times and get a different story each time. Crazy, right? All right, here we go. Halfway done, almost. All right, number 5. A password is 4 letters followed by 1 digit. Uppercase letters and lowercase letters may be used and considered different. How many different passwords are possible? All right, so here we go. How many different passwords are possible? All right, so if you want to pause it and try it on your own, I encourage you to do it. But here we go. Let's think about what we know. We're going to have digits, we're going to have letters. How many digits are there that we can use? 10 digits. What about letters? Okay, well, they tell us that uppercase and lowercase letters are considered different. That means I have 26 lowercase letters, A through Z, 26 uppercase letters, A through Z, which is a total of 52 different letters I could choose from. I could choose a capital B or a lowercase w. Both are fine. 52 different letters to choose from. All right, so now what's this password going to be? It's going to be 4 letters followed by 1 digit. So I'm going to put 5 blanks up there. And I color coordinated it so it would be helpful for you to see. 4 letters, that's orange. 1 digit, that's blue. Okay, so how many different options do I have for each letter? I have 52. How many different options do I have for my digit? Only 10. So how many different passwords are possible? 52 times 52 times 52 times 52 times 10. Mr. Weber, this is going to get really big. Yes, it's going to get really, really big. Okay, it's not wrong. It's just big. Grab your calculator, figure out what it is. Beep, boop, 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 beep, boop, boop, boop. 73,116,160. Yeah, told you, gonna get big. All right, that's the fundamental counting principle at its basic level, that we're just gonna multiply the different options we have for each category or event or choice that we're looking at. Okay, now 6 through 10 kind of changed the game a little bit, all right, because in 1 through 5, everything we did, or for the most part, most of the things that we did, we could reuse the same thing multiple times. Like if you think about this password, I could have my password be A if I wanted it to. I could repeat that letter more times. So the number of options I had stayed the same each time. All right, from here on down, that rule may not be true. Think about the pizza toppings problems. We're going to be thinking about that. All right, so here we go. How many ways can a student government select a president, a vice president, a secretary, and a treasurer from a group of 6 people? All right, so here's our criteria. Here's our 4 positions. They're going to select a president, a vice president, a secretary, and a treasurer. Okay, so we'll do this one at a time. So how many choices, if we're voting, let's say we vote for president first, how many choices do we have to choose from? Well, there's only 6 people in our group, so there's 6 different people that could be in that role. Does that make sense? Okay, now here's where it gets a little bit tricky. Could the same person be both the president and the vice president at the same time? And the answer is no. Okay, so once we've chosen someone for the president, they cannot be vice president, which means the number of options that we have is not the same. All right, so how many options do we have for vice president now? Only 5, because one person is our president. All right, once we've chosen a president and vice president, how many options do we have for the secretary? Only 4. And then for our treasurer, only 3. I mean, you got to feel bad for those 2 people that don't get chosen at all, right? Ugh. All right, so what are we going to do? We're going to multiply 6 times 5 times 4 times 3 to figure out how many different ways can we form this group. Can we select these people? And it's 360 different ways that we could select a president, vice president, and secretary from a group of 6 people. It's crazy when you think about that. Like, there's only 6 people, but yet there's 360 different combinations or ways that we could do that. Really, it's not a combination. It's really a permutation, but we're going to get to that. All right, here we go. 7. How many ways can vases be arranged in a row in a store display if there are 8 vases to choose from? Okay, 8 vases to choose from. I can only put 5 in the store display. So here's my display. I have 5 choices. Notice on all of these, I start off by just thinking about what are the different options that I have to select. All right, and I use the lines because it keeps me from doing this wrong. So I have 5 different options, 5 different places to put those vases, 1, 2, 3, 4, 5. How many vases do I have to choose from when I put that first vase down? I have 8 I can choose from. All right, now the same vase, there's only one vase, right? There's each vase is its own. I can't have the same vase occur more than one time because each vase, there's 8 different vases. So if whatever vase I put in that first slot, I can't put it in the second slot as well. I can't be in both at the same time, which means that I only have 7 options of vases to put in that second position. Okay, now I've put 2 vases down. I have 3 open spaces, but how many vases do I have left to choose from? Now I only have 6. Once I choose that third vase, how many options are left? 5, and then 4. Multiply those things together. Grab your calculator. Beep, boop, 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 beep, boop, boop, boop. And there you go. 6,720 different ways to arrange 8 vases and a store display that only holds 5 vases. Okay, number 8. My animations got messed up. I apologize for that. But a costume contest has 18 participants. How many ways can most creative, silliest, and best costume be awarded? If no one gets more than 1 award. Okay, 18, 17, 16. All right, what are our categories? We have most creative, silliest, and best. All right, so we have 18 participants. So there's 18 people that could be chosen for that first category. Whoever gets chosen in that first category, we're going to assume that no one gets more than 1 award. So there's only 17 people that could get the next category, then only 16 people could get the last category. Multiply those things together. Beep, boop, 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 beep, boop, boop, boop. 4,896 different ways that we could select these three winners. That makes sense? All right, we got two more problems. We're doing great. We're almost done. All right, number 9. A two-digit number is formed using only the digits 5 through 9. How many two-digit numbers can be formed if repetition of digits is allowed? Okay, we're going to take this a little bit at a time. All right, so we're going to start with, there's only going to be 2 numbers. So a two-digit number is formed. So I only have 2 slots. Okay, so how many digits do I have to choose from? Well, they tell me I can only use the numbers 5 through 9. 5, 6, 7, 8, 9. That's a total of 5 different digits. So I only have 5 different numbers to choose from. All right, so when I go to put my first number down, I'm going to put 5 different options because there's 5 digits I have to choose from. Now the question is, what can I do with the next number? Am I allowed to use the same number that I just chose? Okay, if I let's say I chose 7 for that first option, am I allowed to use 7 again? That's the question. All right, this says if repetition of digits is allowed. Repetition means repeat. So it means numbers are allowed to repeat. So I have 5 options for my first selection. I'm still going to have 5 options for the second selection. Okay, so this is a key word you're going to have to kind of highlight, circle, and keep in mind. Repetition means repeat. And when things repeat, the number of options does not change. It stays at 5. Okay? Or not always 5, but depending on whatever the problem is, it's going to stay the same. Multiply those together, 25 different options. Easy peasy. Okay? Now, look at part B. They're changing the game. How many different numbers can be formed if repetition of digits is not allowed? Okay, so we're still having 2 numbers. We're still having a total of 5 different options to choose from because we're choosing only the numbers 5 through 9. 5, 6, 7, 8, 9. That's 5 different digits. When I select that first number, it's still only 5 possible digits that I can choose from. But now they're telling me that the repetition is not allowed. I'm not allowed to repeat numbers, which means the number I chose first, I cannot choose again. All right, so now I don't have 5 options for that second slot. I only have 4 options. 5 times 4 is 20, and I'm done. 20 different ways. Notice how changing that one rule affected our probability. So anytime you are allowed repetition, you're going to have more options. If you do not allow repetition, then the number of choices you have will decrease and the number of total options will be smaller. All right, so repetition means repeat. If repetition is allowed, then your options do not change. If repetition is not allowed, then the number of options will decrease depending on how many you select. Okay, I hope that makes sense. One more problem. How many different ways can we arrange the letters in the word math? This is going to be a great one, even though I messed up my animation. All right, so here we go. So there are 4 letters in the word math. M-A-T-H. Okay, 4 letters in the word math. How many ways can we arrange those letters? So I have 4 letters. All right, so when I say arrange, we're trying to like rearrange them. Let's like, for instance, I could say T, M, A, H. That would be a rearranging of the letters. It doesn't have to make a word. Okay, we're just going to rearrange the letters. Does that make sense? Okay, that was just an example. Let me erase all that stuff. All right, so when I go to choose this first letter, how many different options do I have? I have 4 different options because there's 4 letters here, M-A-T-H. All right, but whatever the letter we chose, let's say we choose the T first, that T is gone. Now how many options do I have? Only 3. Let's say I choose the M, it's gone. How many different options do I have? 2. H is gone, only 1's left over. 4 times 3 times 2 times 1, 24. And that, my friends, is the fundamental counting principle. What you have to think about is how many different options or choices do you have at each selection, and are you allowed to repeat your choices? And that's going to affect the number of choices you have going forward. Okay, keeping those two things in mind, you should be doing great. If you have any questions at all, please don't hesitate to reach out to us. We are always here to help, and you guys are doing great. Just keep doing what you're doing. All right, have a good one.